Hello and welcome. This is going to be our lecture video for March 8th. Let's go ahead and get started. Our goal for today is to be able to solve systems of equations problems using graphing when the equations are not given in slope-intercept form. So they're typically given in standard form, but they could really be given in any form. And we should still be able to solve them using this technique. Why are we doing this? So we can find the solution to any system as long as the answer is integers and we have a graph. So one of the limitations here is if you do graph them and they don't intersect exactly at a Cartesian point, if you want to be very precise, we have to go with one of our algebraic methods. You could give a rounded answer with a fair degree of precision, but if you wanted to be, get it to the exact decimal, then you have to use an algebraic method. But as long as our answer is one of those intersections on a graph, we should be able to find it using this method, regardless of how the equations start, because we know how to convert our equations into slope-intercept form. All right, these problems are on a worksheet linked on our extra stuff calendar, but if you have graph paper, you can just do them on graph paper. You can print off the worksheet, or you can just follow along with the problems as I do them here. All right. So these two problems solved by graphing. We'll start with this very first one. What I'm going to do is graph that first equation by putting a point at its y-intercept of 5 and then attaching the slope of -4. That slope of -4 I might want to turn into a -4/1 so that I can apply rise over run to this. I want to rise -4 and run 1. Rising -4 means go down 4. So I go down 1, 2, 3, 4, and then a run of 1 means go right 1. So this is what a slope of -4 looks like. It's pretty steep and it's going down. I can keep that pattern going of going down 4, right 1. Sorry. All the way across the graph. So down 4, 1, 2, 3, 4, right 1. Down 4, 1, 2, 3, 4, right 1. Keep that going, or reverse it and go up 4, left 1. So 1, 2, 3, 4, left 1. And you see that this point is in a line with all of the other points I've graphed so far. All right, let's connect those up with a straight line here. So this line represents all of the ordered pairs that make the top equation true. Now let's graph our second one. It's got a y-intercept of -9 and a slope of 3. I can make that 3 into a 3/1 if that's easier to graph, because that means go up 3, right 1. 1, 2, 3, 1. 1, 2, 3, 1. I see that that's where they're going to cross. Just for fun, let's keep this graph going all the way across the graph. Connect it up with a straight line. And we get a solution, and we should write our solution as an ordered pair right there of its x value is 2 because it's right underneath the 2, and its y value is -3. It's right across from the -3. So our answer is 2, -3. All right, you can pause the video, try this next one on your own, or just watch as I do it. I'm not going to talk this one through because it's very similar. We'll just see if we get the same answer. There's my first line. The second line in there. Once I can see the intersection point, not super crucial. I get every point on that line. And this one had a solution of 2, 1. All right. Now with this next one here, we have two equations that are given in standard form. We're going to need to convert those to slope-intercept form. So let me show you how we do that. We'll start with our equation with a little bit of space. We always move the x over first. Leave in mind a 3y equals -x plus 6. Notice I put the -x in front of the 6, so the side looks more like mx plus b. Divide everything by 3. And I need to rewrite this as y equals -1/3 x plus 2. Notice I take the x off the top of this fraction and leave a 1 behind. All right, so that should be easier to graph for our first one. Let's do the same for our second one. So x minus 3y equals 6. Let's subtract an x. Get negative 3y equals negative x plus 6. Divide everything by negative 3. And this time we get y equals 1/3 x minus 2. All right, so I'm going to be graphing this one and that one I just wrote. Start with that first one, y-intercept of 2. Slope is negative 1/3. So the negative means I go down 1. The 3 means I go right 3. So down 1, right 3, down 1, right 3. Rise over run, or reverse it, go up 1, left 3. And you'll notice these stay in a straight line with those other points. All right, and then this one here, y-intercept of negative 2, slope of 1/3. So because it's positive, I'm going to go up 1, right 3, up 1, right 3. I can see my intersection point there. So let me just connect these up. Keep the line going all the way across if you want to, but I can see my solution is that point right there of 6, 0. All right, this next one is back to slope-intercept form, so we don't need to convert it. I'll try this one real quick. We don't see a slope here, so we can infer that it's a 1, which we can then turn into 1/1, which means go up 1, right 1. To get these points, and then reverse it, go down 1, left 1 to stay on a line. Go in this direction. All right, and then for our next one, we don't see a y-intercept, so we can infer that the y-intercept is 0. If we don't see a slope, the slope is 1. If we don't see a y-intercept, the y-intercept is 0. So this equation starts at the origin, and then a slope of negative 2 means go down 2, right 1, down 2, right 1, all the way across the graph. Come back this way. We can see where they cross. They cross at this point right here, and we need to write the coordinates of that point. It's directly above the negative 2 and across from the 4. So negative 2, 4 is the location of that point. Okay, I have a few more for you to try on that worksheet. I won't solve them here unless is there. Let me just look at them real quick. I think, yeah, you should be fine to solve all of these using the techniques we just talked about. I'll embed a few more for you to try as our exit ticket. Or, yeah, I'll just use these problems as the exit ticket. So, because we got 4 problems right there. So I'll embed these 4 as our exit ticket. I'll call that good for our video today. So once you solve those, you're done. Have a good rest of your day.